Okay, we are starting now on Math 102, asymptotes of a rational function or asymptote of a function. Are you there? Okay, some of you have already attended the lectures, right? In school. And I won't be talking much on this, but I will try to explain for proper understanding. When you hear the word asymptotes, what comes to your mind is a straight line. A straight line that is parallel to horizontal axis or parallel to what? The vertical axis of a Cartesian plane, or that is even slants, or that forms an angle, a certain angle with either the vertical or what? The horizontal. Right there. Either parallel to the vertical axis or parallel to the horizontal axis or oriented at an angle. I will explain. So when you hear the word asymptote, what comes to your mind is a straight line. A what? A straight line. This straight line can either be parallel to what? Horizontal what? Axis, abi? Or parallel to what? Vertical axis. Or that same line can either be what? Oriented at an angle. Theta. Either. We call that what? An asymptote. For example, if I have a graph like this, what do we call here? Y what? What do you call here? S-axis. Thank you. If I have a straight line, let's say I have a point B here, and I have a point what here? A point called C. If I have a straight line that emerged from this point, that is parallel to what? To the S-axis. These two lines are what? Are parallel. Do you get the concept here? We call this what? The asymptotes. The horizontal what? Asymptotes. The horizontal asymptote is a straight line that is parallel to what? Horizontal what? Axis. But that asymptote must meet what? The y-axis at a certain point called what? B. Do you get the concept here? If you draw a straight line here, if you remember when I taught you guys how to plot a graph, we say y equals to, I think, mx, right? Plus what? Plus c, right? And I say that if slope m is equals to 0, meaning if I have a graph that has no slope, what will be the function? Y equals to c, abi? Because 0 times s is what? 0. I mean, y equals to c. So such kind of graph will look like this. Y-axis. Here we have what here? S-axis. So here, y is equals to c, meaning the graph is a straight line graph that is parallel to what? To what here? S-axis. So we call this what? The horizontal what? Asymptotes. Are you there? But for a graph of y equals to ms plus c, how would the graph look like? We have y-axis, right? And we have what here? S-axis. A graph of this will start from here, right? Is that not? It will cut the y-axis at a certain point. We call this what? Slant. Abi? This is called slant. So that means that asymptotes can either be of 3 types. We have what we call the horizontal what? Asymptotes. We have the slant what? Asymptotes. And we have the vertical what? Asymptotes. How does the vertical asymptotes look like? This is for horizontal, right? Let's say I have a point C, and I have a line that is what? Parallel with what? The y-axis. Cutting the s-axis at what? At point C. Are you there? At this point here, we are saying that our x, right, is equals to what? C. For this, if I have B here, what are we saying here? That y is equals to what? B, right? But here we are saying, okay, let's use the word C here. If here is C, y equals to C, right? When your m is 0, that means that here becomes what? Y equals to what? So C. So, but we can use any alphabet to represent the value. So I think in your textbook, they use what? B, right? And they use what here? C. But what I'm just trying to say is that we have 3 types of asymptotes, we have what we call the vertical what? Asymptote, which is parallel with what? The y-axis, and which meets our x at a certain point what? C. We have the horizontal what? Asymptotes, and we have the what? The slants. And that word, another name for slants, is called the oblique. Oblique. Either oblique or what? Or, but I don't know if the woman touched this part. Did she touch this part? Those attend the class. You attend the class now. She didn't mention slant, but she mentioned vertical and horizontal. She's meant to mention slant. Maybe she omitted it or what. Oh yeah, please write. Put this on. I've defined an asymptote, right? I say it's a straight line that is parallel to either the vertical axis or parallel to the what? Horizontal axis, or oriented at an angle, right? And I'll give a diagram. This is a diagram that contains the three. Here we have y, we have b, yeah? Here we have y equals to b. Here we have s equals to what? C. I can have the third one, right? Which is what? Y equals to what? ms plus what? Plus c, right? You can put this graph down as a general graph that shows the three types of what? Asymptotes. Y equals ms plus c. All right. The third line is this now. Slant. Okay, so we are saying that we have here for the vertical asymptote, please note that for the vertical, what happened at the vertical? X, right, is equals to what? C, right? For horizontal asymptote, what happened there? Y equals to what? B. Thank you. Then for the slant asymptote, what happened there? Y equals to what? ms plus c. So put this on. Let's look at vertical asymptotes. Vertical what? Asymptotes, which is a straight line, right? That is parallel with the what? Vertical what? Axis, right? And which meets the s-axis at what point? At s equals to what? C. Are you there? Okay. Now you must have to take note that asymptotes can only occur in a what? Rational what? Function. Are you there? In a rational what? Function. Stop writing and pay attention. Asymptote can only occur in a what? Rational function. Asymptote cannot occur in a polynomial. What's the polynomial? You know, we say we have three types, Abi. We have the linear, right? Are you aware? Linear. We have what? The quadratic, right? And what again? The cubic. Is that not? Cubic. Linear is what's general form of linear? We have y equals to what? ms plus c, Abi. What about quadratic? as squared plus what? bs plus c. What about cubic? as cubed plus what? bs squared plus cs plus d. We cannot have asymptotes of a polynomial. We can only have what? Asymptote of a rational function. What is a rational function? These are functions that have both what? Numerator and what? Denominator. For example, the general form is what? What general form of a rational function? F of x equals to nx, thank you, over what? Somebody? Over dx. Where dx is not equals to what? 0. Is that not? Is that not? This is only where we can experience what? An asymptote of what? Of a function. What kind of function? A rational what? Function. Where we have both what? Numerator and what? Denominator. And we say that the condition for this to exist is what? Your ds must not be equals to a 0. Do you get the concept? Now, let's go into our vertical asymptotes. Vertical what? Asymptotes. Vertical asymptote of, can I clear here? Of a rational function. of a rational function. Okay, which is ns, right? Over what? Over ds. Is that not? Of a rational function. Okay, look at this. Look at this. Please write. Put this on. Let me give you a note. Then we'll look at some examples. To determine a vertical asymptote for a rational function, to determine a vertical asymptote of a rational function, that is f of x equals to nx over what? Over dx. Nx over what? Dx. We use the roots of both the numerator and we use the roots of both the numerator and the denominator to test for the asymptotic behavior. We use the roots of both the numerator and what? Denominator to test for the what? Asymptotic. Asymptotic what? Behavior. Asymptotic behavior. Are we there? Put this down. Step to show vertical asymptotes. Number one, find the root of the denominator. Step to show vertical asymptotes. Number one, find the roots of the denominator by setting, find the roots of the denominator by setting, which of these is our denominator? The s. By setting the x equals to what? 0 and find SD and find SD and find SD. I will explain. I'll give you an example. Then I'll also tell you the shorter way to solve without passing through these steps. Number two is that we have to find the roots of the what? Numerator by setting what? What would that be? By setting what? Nx, right? Nx equals to what? 0. And what, yeah? And find what? Sn. And find Sn. Meaning SD means find the roots of what? Of what? Denominator. So SD means what? The root of what? Denominator. Sn means what? The root of our numerator. Do you understand the concept? For example, if I have, let's see if I have f of s equals to 2s plus 4 over 3s plus 5. How do we find the root of the numerator? I will say 2s plus 4, right? Equals to what? 0. Is that not? That will give us 2x equals to what? Minus 4. What's my x here? Minus 4 over 2, which is what? Minus 2. That means what? Our s what? SD equals to what? Minus 2. Do you get the concept here? SD means, sorry, Sn, thank you. Our Sn equals to what? Minus 2. Because we set what? Our n, our what? Ns equals to what? 0. So anything you have becomes your what? Your Sn. Abi? If I'm to set this as 0, what would be my value of x? Will it be Sn or SD? SD. Is that clear? Good. Now let's proceed and find Sn. Now, what's the first step? I said again. Read for me. Okay. Okay. Agula. That's the first step now. The second is this, Abi. Oh, yeah, right. Rules of occurrence. Rules of occurrence. What shows that we have a vertical what? Asymptote? What really shows that we have a vertical asymptote? We'll look at it here. We'll look at it here. Under the rules of occurrence. Now listen. If if the roots of what? The denominator is equal to the root of our numerator, there is no vertical what? Asymptote. There's no what? Vertical asymptote. But if the root of the denominator is not equal to what? The root of the numerator, what happens? There is a what? A vertical what? Asymptote. I will give an example. Then I'll give you the shorter way to solve this. Put this down. This is the rule of occurrence. If st, the roots of the denominator, equals to that of a numerator, it means there is no vertical asymptotes. Then if they are not equal, it means there is a vertical what? Asymptote. Example. If we are given f of x equals to 1 divided by x minus 3, and the question said find the vertical what? Asymptotes. VA means what? Vertical asymptotes. Who can remind me, what are the types of asymptotes we have? What are the types? And what, somebody? Also, again, is slanty. And manu slanty answer to. And now what for slant is what? Oblique. Oblique, Abi. We have oblique or slant, Abi. We have horizontal, right? And we have what? Vertical, right? Your lecturer stopped here. Lecturer stopped here. People learn only horizontal and what? And vertical. Are you there? But I will extend my class to what? Oblique. Now, we are asked to find the vertical asymptotes. What did I say in general? What is the general rule of finding vertical asymptotes? We set what? We set what? Denominator equals to what? 0. Is that not? But from the first rule I gave us, what is the first rule? I said we have to find what? SDRB by setting what? DS equals to 0, right? Also find what? SN by setting what? NS equals to 0. Is that not? Then I say that if NS and if SD and what? SN are equal, what happens? No vertical asymptotes. Is that not, somebody? But if they're not equal, there is what? A vertical asymptote. But for this function, we don't have a polynomial here in the word numerator. So no need of finding what? NS or SN. Do you get the concept here? I say, okay, let me give you an instance. Listen. If my function is equal to, let's say, 2x plus 5, and I have here as 3x plus 6, and they say find what? Find vertical what? Asymptotes, right? We have a polynomial, we have what here? A polynomial. What do we do? We set this equals to 0, find x. Set this equals to 0, also find what? X. If the two s are not equal, it means there's a vertical what? Asymptote. Is that not, somebody? But here, do we have any polynomial here? So what do we do? Just set only what? Denominator equals to what? 0. Do you get the concept? So solution here is that we have to set. We set x minus 3 equals to 0. By the time we set, what is our x here? X becomes what, somebody? 3. Is that not? Yes. Is that not? So here we have, there is a what? Vertical asymptote at what? At SD equals to what? 3. Put this on. There is a vertical asymptote at SD equals to 3. Here we are given equation 2. We are given f of s equals this, right? Are you there? How do we say we solve this? What is the first step? I said we have to set Abi. We set what? NS, right? We set NX equals to what? 0. To find what? To find SN, Abi. So what do we have here? We have 2s plus what? 5 equals to what? 0. So that means 2x equals to what? Minus 5. What's my x here? Minus 5 over 2. What s is this? SN, Abi. Do you get the concept here? So also, we have to set what? Dx equals to what? 0, abi? What's our dx? 3s plus what? Plus 6, right? Equals to what, yeah? 0. So what do you have? We have 3x equals to what? Minus 6. Is that clear? Okay, so what do you have here? Our s becomes what? Minus 6 over what? Over 3 equals to what, yeah? Minus 2. Okay, here we have, here becomes what? S what? SD. Is Sn equals to SD? So since Sn is not equal to SD, what will be the asymptote? There is what? Therefore, there is a vertical what? Asymptote at what? At SD equals to what? Somebody minus 2. Let's see if we are given fx equals to, let me say we have 5x plus 10 divided by, there we have this, x plus 2. Find, and I say find VA, and s plus 2. There is no vertical asymptote, but there is horizontal. I've not entered horizontal, right? Let us analyze vertical first. What do we do? Solution is that we have to set, abi? We set what? The x, sorry, ns, right? Equals to what first? 0. What do you have here? 5s plus 10 equals to what? 0. So that means 5x equals to what here? Minus 10. What's our x? Minus 10 over what? 5, abi? What's the answer? Minus 2. We also set, abi? We have to set what now? Ns, right? D of x, I'm always missing this. D of x equals to what? 0. What's the d of x? S plus 2 equals to what? 0. So what do we have here? We have x equals to what? Minus 2. Which s is this one? S what? N, abi? What about this? This is my SD. Since, right? Since Sn is equals to what? SD. It means there is what? Eh? There's no vertical what? Asymptotes. Do you understand? They are equal. There's no vertical asymptotes. That's what it means. But this is very rare to see. That's why I say 90% of your question is all about setting this equals to what? 0. It's very rare to see this. It's rare. Given example 4, right? Given that f of x is equals to 3x minus 6 divided by s squared plus minus 7x plus what? Plus 10. I don't think she gives something like this, right? Did she give you guys something like this? I know she will not, because that method she gave is limited. I can't use it here. This will give us, the value of x. 2. What about this? 1. Do you understand the concept? So what do you do here? Is to factorize both of them. I will factorize. Factorize the numerator. I'll factorize ns, abi? And what? And dx. Factorizing our ns to be equals to what? 3s minus 6. What would that give us? 3, abi, in bracket, what will be here? X, minus 2, abi. So let's factorize. Factorizing dx. What's our dx? S squared minus 7x plus what? 10. Right? Right? I want to believe we all know how to factorize. What's the first term here? S squared. What's the last term? Multiply the first term and the last term. What do we have? 10 what? S squared. So think of two numbers, right? When you multiply them, you will have what? 10x squared. But when you add them, what we have? Minus 7, Abi? Minus 7. Think of two numbers. When you multiply them, you have this. When you add, you must have the central term here. What do we have? Minus 5x and what? Minus 2x. Let's verify. Minus 5x times minus 2x is what? 10x squared. Minus 5x plus minus 2x is what? Minus 7x. Then I can replace these two terms, Abi, with what? With 7 minus 7x. Can we do that? That will give us our dx equals to what here? X squared minus 7x minus what? Sorry, minus 5x minus 2x plus what? 10, Abi. So our dx becomes what? What's common here? Thank you, x. What's the meaning here? S minus 5 minus, right? What's common again? Minus 2 is common, right? What will remain here? S minus 5. Okay. What do we have? What are the common terms here? S minus 5. If S minus 5 is common, here becomes what? X minus 2, Abi. Good. So my dx is equals to this. What do you notice? Let's see how we can solve this. You will now find out that, connect me here. Therefore, our f of x, which is equals to what? 3x minus 6 divided by what? S squared minus 7x plus 10 will now be what? Who can tell me? What would that be? F of x equals to, what do we evaluate this as? 3 into what? S minus 2 over what? What about this? S minus 5 and what? Minus 2. Are there common things that can cancel out? This, Abi. So that means our f of x is equals to what? 3 divided by what? S minus 5. This is now looking like the first example I gave, Abi. Where we have a number and what? And what? A polynomial. Is that not? So what do we do here to find our VA? We have to set our ds equals to what? 0. Right? So we say set ds equals to 0. That means x minus 5 equals to 0. It means my SD is equals to what here? 5. Final answer. It means there's a vertical what? Asymptotes at s equals to what? 5. Therefore, there is a vertical asymptote at SD equals to what? 5. Put this down. Question number what now? Number 5. Just only here. I'm cleaning just here. I'm not cleaning everything. Question 5. Find the vertical asymptote of y equals to 4 divided by, here we have, I think we have s squared minus 16. S squared minus 16. Solution to this. What do you think? This example here looks like something this, right? Do you get the concept? So what do? We have to set what? Denominator equals to what? 0. So we say set dx, right? Equals to what? 0. When you set of dx equals to 0, that will give us what? Yeah? S squared minus 16 equals to what? 0. I can use the principle of difference of 2 squared to factorize, right? What would that be? S squared minus what? 4 squared equals to what? 0. Then what is the principle here? Recall that if we have a squared minus b squared, what is the result? A plus b times what? A minus b. We call this what? Difference, Abi, of what? 2 squared, right? So that, what do we do here? How can we apply it here? What will be the result here? X. Therefore, s squared minus what? 4 squared will be what? S plus 4, times what? X minus 4, all equals to what? 0. So this becomes x plus 4 equals to 0, or x minus 4 equals to what? 0. So what would that be? Therefore, what's the first one there? Our SD is equals to what? When you move this plus 4 across this side, or when you subtract 4 from both sides, what will be our SD here? Minus 4, right? Or what? Thank you. 4, or SD equals to what? Somebody? 4. Final what? Answer. Final answer. What if we are given that f of x is equals to 8 over s squared. 8 over s squared plus 4. Find VA. There's nothing like sum of 2 squared. Why solving this? So please take note. Solution to this is that we need to set. We have to set what here? The x equals to what? 0, right? When we set what we have, s squared plus 4 equals to what? So plus 4 equals what? 0. How do we solve for x there? Since there's nothing like sum of 2 squared, right? We move this 4 to the other side, right? It becomes what, yeah? S squared equals to what? Minus 4. To find s, what do we do? We square root Abi. Square what? Roots both what? Both sides. That will give us x equals to what? Root what? Minus 4. And what's with minus 4? This is same as what? Root minus 1 times what? Root 4. We have learned this now in complex number, right? That it is practically impossible to find the root of a negative what? Number. The value of this x must give us what? An imaginary number. Is it not? Root minus 1 times 4 is same as what? Root what? Minus 4. What do we say is root minus 1? A complex number. I. Right? Here becomes what? Yeah? I times what? What's root 4? 2. What's 2 times I? 2i. So that means that our SD is equals to what? 2i. Listen, if SD is equals to 2i, do you think there's a vertical asymptote or not? There is no vertical asymptote. Do you know why? Because I have an imaginary. There's nothing like imaginary vertical asymptotes. From your graph, what's your graph saying? Yes, 0 B. This is what? 1, 2, 3, 4, right? All the numbers here, are they real or imaginary? They are real. So vertical asymptote will say it's a straight line, right? That is parallel to what? Parallel to the y-axis. It means it's parallel. It's a graph that is meeting the real value of x, not imaginary. Are you getting the concept here? So at this point, they will say that x, Abi, is equals to what? So it's A we use, right? Was it A or B we use? C. Okay, x equals to what? C. But that C must be what? Real. So we don't have anything like imaginary, vertical. We only have what? Real, vertical what? Asymptote. So since SD gives imaginary value, right? Imaginary value, which is 2i. Therefore, there is no vertical what? Asymptote. So we can say that vertical asymptote is what? None, Abi? Just write none. Okay, question what now? Question 7. If we are given this, the f of x equals 10s squared minus 5s minus 15 divided by 6s squared minus 17x plus 12. Then we are also find vertical what? As asymptotes. Now look at this now. Who can tell me what do we do here? In this case, we have polynomial here, Abi, in our ns and what here? ds. Both ns and ds are what? Polynomial. Do you get the concept of the same what? The same degree. Is that clear? So we have to find the vertical what? Asymptotes. Are you there? If we have to find the horizontal asymptotes, my answer here is 10 over 6. But let me not go into that first. I'll give us another subheading called horizontal asymptotes. Why did I say it's 10 over 6? The degree of what? The numerator and the degree of what? Denominator is what? The same. What the degree here is 2. What the degree here? 2. Degree means the highest power. Are you there? What the highest power here? 2. What about here? So divide this 10 by 6. That will give us what? The horizontal what? Asymptotes. We have 3 test conditions to determine if a function is what? Horizontal asymptotes. Is when the first is when n is greater than m, when n is less than what? M, then when n is equals to what? M. But when n is equals to m plus 1, we have what? A slant what? A slant asymptote. I'm coming to this. Are you there? I don't know. I don't think if your lecturer captured this. She captured it too. Awesome. Okay. This is for under horizontal. Don't bother writing. I'll give you the notes. For this, now what do we do? But we have to find vertical. Vertical is different from horizontal. The only condition or steps we have for under vertical is that what we do, we have to set our ds equals to 0, b. But for this, what do we do first? We have to factor. We factorize both this and this, right? And look for maybe any common factors to cancel out, right? After canceling, what do we now do? We now have to set what? Our ds equals to what? 0. Are you there, somebody? Or we find our ns, find our dx, then check if they are what? The same, abi? If that is, that means there is no what? Vertical what? Asymptotes. But if our ns and our what? Dx, so sn rather, and what? Sd are not the same, what do we say? There is a vertical asymptote, right? Let's find out. So we have to factor out. Factorizing dx and what? And ns, right? Okay, so for ns, let's start with ns. What's the ns saying? 10x squared minus what? 5x minus 15, right? Are you there? Okay. So what do we do here? How do we factorize this? Let's show the simplest way. Look at this term here. They have a common term, abi? Can I say this is same as what's common among them? Thank you. 5 in brackets. What will be here? 2, right? 2x squared minus what? X. Minus what? 3. I will now factorize this now. I've reduced this, abi? It's now easy to factorize. Can we now factorize now? Multiply 2x squared by 3. Minus 3, what do you have there? Multiply 2x squared by minus 3, what do you have there? Minus what? Minus 6x squared, abi? Is that not? Think of two numbers that when you add them, when you multiply them rather, that will give us minus 6x squared. But when you add or subtract, it will give us what? Minus x. Minus what? Minus 3x and what? Plus 2. Plus 2x, right? Do you know why? Minus 3s times plus 2s is what? Minus 6s squared. Minus 3s plus 2s is what? Minus x. So that means I can replace them with what? 5 in brackets. Abi? What do you have here? Let's go. 2s squared. Minus 3x plus 2x minus 3. Okay, okay, let's finish up this. So we have 5 in bracket. What is common between these two men? X. What's the meaning here? 2x minus 3, right? Are you guys following? Okay. Between these two, what is common? Plus 1, abi? What do you have here? 2s minus 3. How do you know your answer is correct? Yeah. Is when the same thing you have here, the same thing you have here, right? Hope you're aware. By the time we expand this, 1 times 2s, I'll fall back to what? 2s. What's 1 times minus 3? Minus 3. Okay, so that means that this becomes 5 in bracket. What is common between these two? 2x minus 3, abi? Times what, yeah? S plus 1. Let's stop here for what? For ns, abi? Now, what's the next we are looking for? ds. So, for ds. For ds, so let's go. We have to set this, abi? Let's go for the s. Okay, sorry, let's find the s first. What's that the s there? 6s squared minus what? 17s, right? Plus what? Plus 12. In this case, there's no common number that can divide, abi? So I will just have to multiply the first term by what? The last term. Okay, yeah? 6s squared times 12 is what? What is 6 times 12? 70 what? 2s squared, Abi. What are the two numbers that when you add, when you multiply them, will give us 72s squared? But when you add or subtract, will give us what? Yeah? Minus what? 17x. Minus what? Are you sure? Minus 9x and what? Minus 8x. Will this two go? Okay, so let's see. Minus 9x times minus 8x is what? So when you add them, we have this, Abi. So let's go. So our dx will then be what? 6s squared, right? Minus what, yeah? 9x minus 8x plus what, yeah? 12. So what's our dx? What is common between these two men? 3s is common, right? So we have 3s common. What was many here? 2s, right? Minus what? 3. Thank you. What about this? What's common? Minus what? Minus 4 is common, right? What's many here? 2s plus what? Minus what? 3. Hope you're aware. When you evaluate this, you will fall back to this, right? So what are the common factor here? So dx becomes what? 2x minus 3, right? 3x minus what? 4. Already you are saying something, right? There's something common here. So this we cancel this automatically. But let's bring it out. Therefore, our f of x will give us, what are the factors of this? This, Abi, ns is this, Abi. Can I bring out this as my ns? That will give us what? 5, times 2x minus what? 3, s plus 1. Are you following? Divided by what, yeah? 2x minus 3, and what? 3s minus 4. Which of these numbers we cancel out? I hope you are aware that this is saying 5 times this. So this we go with this, right? So what's our fx remaining? 5 times s plus 1, Abi, over what? 3s minus 4. From the first rule I gave us, I said to find VA, vertical asymptote, what do we do first? We have to set the s equals to what? 0. Set ns equals to what? 0, Abi. When you set to ns equals 0, you find what? Sn. Abi. When you set to the s equals 0, you find what? SD. If your SD and your Sn, Abi, are not what? Equal, it means there's a vertical what? Asymptote. At what point? At that point, SD, Abi? Good. But if your Sn is equals to what? SD, it means there's no. But looking at this, is there any need of me even saying less this equals to this? There's a vertical asymptote. Do you get the concept? The value of S here and here cannot be the same. Do you get it now? So what do you want? Should we just go straight and say let's the s equals to 0? We will solve it, Abi. Okay, right. Put this down. But for me, I will just say let the s equals to 0. 3s minus 4 equals 0 now. Your s equals to what? 4 by 3. It means there's a vertical asymptote at what? S equals to what? 4 by 3. Are you getting the concept? If you set this equals to 0, you can't have the same value of ss here. It's not possible. Because there's no common factor. Is it not? We set our nx equals to what? 0, right? To find what? To find Sn, right? So let's go. What do you have there? Let's go. What's our ns? 5s plus what? 1 equals to what? 0. Can we expand this? What's 5 times x here? 5s plus 5 equals to what? 0. So here we have 5s equals to what? Minus 5. S becomes what? Minus 5 over 5. What's the answer? Minus 1, Abi? Also, we have to set the x equals to what? 0. What's that the x? 3s minus 4 is equals to what? 0, right? So that means here becomes our 3x equals to what? 4, right? What be here? Our x equals to what? 4 over what? 3. Which s is this? This is Sn. Which s is this? Sd. Is Sn equals to Sd? No. So we say since Sn is not equals to what? Sd, it means there is a what? Vertical what? Asymptote, right? At what? At Sd equals to what? 4 over 3. Thank you. Like I said, alternatively, if you don't want to put this equals 0 or this equals 0, just set only what? Your ds. You can start from here. Once you get to this point, you can start from here. Looking at the nature of your equation, you know that they cannot be the same. You know. Just start from here and say set what? ds equals what? 0. Then any value of s you have here becomes what? Your vertical what? Asymptotes. Is that clear? But this is exactly what was captured in your textbook. Yes. The denominator. Yes. In other words, like she asks, the vertical asymptotes only occur at what? Your denominator, your ds. When you set your ds equals to what? 0, you obtain the vertical what? Asymptotes. All right. Okay. Subheading.